Hi everyone, welcome back. If you want to support me, please press like and press subscribe. Index laws. Okay. Look at my reaction. On a video camera, I'm giving you that reaction. It's almost just sort of go. I see people go crazy on this. I've taught in 3 different states of Australia, and I keep on saying to people, don't go crazy with index laws. There's no purpose to it in significant live calculations, and people just go nuts. Even what I've got here is, I can think of some sort of uses for it in year 11 and 12 in calculations. Let's have a look at them though. They will be assessed on. I know they'll be assessed all across Australia and all across the world. Doesn't matter whose textbook I'm looking at from what country. I'll see index law questions like these. First one. They've got all these other index laws. I've got them with numbers and a whole bunch of them. I've got index laws with numbers 01, 02, 03, 04, 05. You can see them. You can see them on my playlist. And once people get used to it with numbers, then we go to letters, and I've got index law with algebra 01 and 02 and 03. So this is going to go onto that list. Let's have a look what's going on here. When I was at school, I did keep on having trouble with what did this mean with a little 2 there and a little 2 there. This is the normal 3, and that's a little 2 and a little 2. They're referred to as an index or a power or an exponent. That little 2 there, really the whole thing comes back to a long time ago. There was one basic rule made up. The basic rule was made up by a commission of people in Europe who got together and decided a lot of what would happen in algebra. So that 2 means I'm going to write all of what's there twice. So there it is once, and there it is twice, with a multiply in between. So that little 2 there also means I'm going to write everything that's inside there twice. Exactly what we had there, and write it twice with a multiply in between. Then you can look across if you really wanted to. You can go 3 times x times 3 times x and go right through the whole process, which I call write out in full. So if you really need to and you're stuck in assessment and you think, I don't know what to do, I can remember doing it all those years ago when I was in school. I've got a 3 times a 3 is 9, times another 2 is 18, and the numbers start going crazy. And 18 times another 2 is 36. You can pick up your calculator and check that. Now, what happens with these little 2s and the little 3s? When you're multiplying, that base stays the same. The bottom, which we call the bases stay the same. So if they were numbers, they'd stay the same number. Then we add the powers. 2 plus 2 is 4, plus another 3 is 7, plus another 3 is 10. So you can get pretty quick at doing it. I'm going to show you also again, as if I was doing the same question again. That 3 with a squared, 3 times 3 is 9, and I see student after student after student who goes 3 2s are 6. That means write the 3 times itself, there it is there, which is just the 9. Then an x squared squared, the shortcut is you can multiply those 2 numbers there. And you can see here the 2 and the 2 would be a 4. So I can go 2 2s are 4 and write x to the 4. If that works for you, 3 times 3 is 9. X squared squared is x to the 4 multiplied by the 2 squared, so 2 times a 2 would be 4, and the x cubed squared is going to be 3 times 2, and the 3 times 2 is the 6, and you can see here, the 3 and the 3 would give us the 6. So if that works for you, most people after a while get comfortable with that. 9 4s are 36, and then you add the 4 and the 6, which is the rules for if you're multiplying, the bases stay the same, and you add the 4 and the 6 and you get a 10. Have a look at this one here. If I did the write out in full, I've got 10 times x times x times x, and I tried to keep it not too many letters so it doesn't get too confusing. It's annoying when people put things like x to the 9 and y to the 12 and makes it go crazy. And now you've got over 2 times x. Remember, everything has a multiply between them. Multiply, 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 including these ones here. And any multiplication can cancel between the top and the bottom. So now I can go, 2 into 2 goes once. Remember, it does actually go once. And 2 into goes 5. So I've simplified the numbers already. Then I can look at these and I can go y into y goes once, and y into y goes once. If you want to look back at previous videos, I'll talk about that more. Now, I can't cancel any more y's, so there's one leftover y here. So that's going to be there in the answer in a moment. These here, I can cancel that x there with that x there, and if I really wanted to, I can go x into x of 1, but it starts getting quite cluttered, and I don't like seeing my my working out getting too cluttered. So I've got a 5, I've got x and x, that's an x squared, I've got a y, and everything on the bottom became a 1. So if I wanted to, I could put over 1, but I don't have to write over 1 because it means the same as what I've already got written. Some people will look at it, now let's do it again, like this one here, it's almost like this, so start again. You can just go, how many times is 2 into 10? Goes 5. Nice if it works out nice, but if it was a 4 and a 10, it's a bit more complicated. Then you can go 3, subtract 1. Remember when we're dividing, go back to the fact that this is a division. The rule is the letters stay the same and you subtract the powers. Letters stay the same and you subtract the powers of the index. So that's an x, 3 take 1 is 2. So there's my straight to the answer of x equals 2, x to the 2 if you're confident. And it's quite interesting, people can really struggle with their maths and think they're terrible at maths, but get index laws and do really, really well with it. So this one here, there's a little 1 there, so the y stays the same, and the 2 take the 1 is a 1, and we don't have to write the 1. So you can go straight to the answer if you're confident. So I could do that with here, this one here, but the numbers become a bit worse. Probably, I'm always torn, like which way do I do this? Do I multiply the top first? Do I write it out in full? Or do I just go through the basics of what we can get? Now, I am going to ignore the numbers for a moment. I'm going to go x times an x squared is an x cubed. So the x times an x squared is not x squared. There's 1, 2, 3 x's. There's an x times an x times an x. That's an x cubed. There's a y times a y to the 4. It's not y to the 4. I see so many students write that as y to that as y to the 4. It's actually y to the. There's a 1 there and there's a 1 there, if that makes sense to your brain. So that's y to the power of 5. We add the 1, we add the 4. And on the bottom I've got this x and I've got the y squared. And I'm back to a question just like what I had over here in a moment. Here's the big part. A lot of people have trouble with the 3 and the 4 and the 6. A lot of people will look at it and go 3 4s are 12. And how many times does 6 go into 12? And they'll write twice. Some people need to go 3 4s are 12. So I'm trying to think of everyone who's watching this might need help on it. And then you've got a 6 on the bottom. Let's have a look what's going on here. If I had the 6 and the 12, 6 in the 6 goes once, so remember it becomes a 1. 6 and the 12 goes twice. Now let's have a look at the rules on the x's. So that's actually a 2 over 1, which is just a 2. There's a 1 here, remember there's a 1 on top of that x, it's an x to the power of 1, or the index of 1. When you're dividing, the x's stay the same, just like here. And 3 take 1 is 2. And then you've got the y's stay the same. They're the same bases, they stay the same. And 5 take 2 is 3. And the question gets pretty easy. So I do know people who look at it and just go to shortcut the whole thing, but it's up to you whether you're comfortable with it. There's so many more I could do. You can just keep getting more and more complicated if I get a chance. And people want to see some more, I might make some more complicated ones. I hope it helps. If it does, please let your friends know. Thanks.